Hi, Tom Pingle here. I wanted to show a little bit about how to make a cartogram in R. So there are a few different ways to do this. I'm going to show you this way. So this is a tool set that integrates with R and facilitates cartogram construction. It's pretty easy to get going. For those of you who don't have R experience, the first thing that you're going to need to do is install R. You can go to the download page for the R project, and you can pick through and sort of figure out which version you're going to need. So the first thing to do is to identify a CRAN mirror, so that's the Comprehensive R Network, R Archive Network. And if you scroll down to the United States, under USA, you can pick one of these mirrors that's nearby, and it doesn't need to be right next door. Just pick any of these in the same country should be fine. So once you download that, you can install that, and I've done that already. The other thing that you might want to do is download RStudio. So if you go to RStudio here, you've got this version, and you can download the version of desktop here. My suggestion is probably just to get the RStudio desktop, which is an open source license and is free, and you can download and install that. Once you've got that installed, then you can run it. So if we go to, let's just go down here. If we go to our installation folder here, I've got a folder for R, and you can open up whichever version corresponds to your architecture. So I've got a 64-bit machine. So I'm going to run that. And if you look at the first page here, it describes how you need to install this. So you can basically just copy and paste this right into the window. It's going to ask you to choose a CRAN mirror. So again, you'll just want to choose something that's nearby. And it will talk to the server and start making the installation. So this shouldn't be a very big download. It shouldn't take too long. You may have a couple of dependencies that need to go along with it. So depending on what else you've got installed already, this could take just a second or two, or it might take several minutes. So this is a fresh install for me, so it's going to download a few things. I'm going to pause the video, and when it's done, we'll be back. Okay, so that was just another 15-20 seconds or so, and everything has been installed and is ready to go. So to get started, there are several examples here, and you can kind of figure out what's going on here based on the comments. But the very first thing that happens is some libraries have to be loaded. So if we just hit Control-C and go back to our R installation, and you could be doing this in RStudio, we'll load those in there. You can see that we're missing a couple of libraries. So if we hit the up arrow, you can actually install whatever it is that's missing. Oops, I misspelled that. If we put in tmap, then it's going to go and it's going to pull this down. Again, we'll pause the video here while it finishes that installation. Okay, that leaves tmap installed. So if we, again, are just pushing the up arrow here to retrieve previously typed in commands, we had tried to type in library Cardiogram to load that one. We had tried to type in library tmap to load that one. That should load now. And then the last thing that we need to do is load map tools. Now we haven't installed this yet, so we should get another error. So there's no package called map tools. So we'll just install map tools. Now the installation for these will stick after this session is over. So you should only ever need to do this once, but again, because this is a fresh install, I had to install all of these. Okay, so now that that's done, we should be able to load the map tools library and we're ready to go. The next bit here is we're loading a data set. So this is loading a world simple data set, and if we paste that into the command window, it's going to load that into memory. if you're interested in learning more about this, I can show you how to load custom data sets, but we'll, for the purposes of just focusing on cardograms here, we're just going to use the defaults. Now, the next bit here is going to pull out just Africa. So we're pulling out only region 2. You don't have to worry about the syntax too much, but basically what we want to do is we've loaded data for the whole world, and we just want to pare that down a little bit and just use the data for Africa. So it's enough sometimes to kind of get a general sense of what's going on in each line, even if you don't understand exactly what's going on. The next bit here is we're doing a coordinate transform. So you can see that we're doing a coordinate reference system here with an EPSG for 3395. We could look that up on spatialreference.org to see what that is exactly. But probably we've got a local projection here, continental projection for Africa, just to make sure that things look nice. Okay, so if we've done that, we've got a data set here for Africa. You can just type in AFR, which is going to retrieve some information about the variables. And you can see, just sort of spot checking in here, you can see that we've got information about the various countries in Africa. The next bit here is where we're actually constructing the cartogram. So this line here is going to construct a continuous cartogram. So CONT is continuous based on our Africa data set using a population field that's in the data set called 2005. And then we're specifying a number of iterations. So the way that continuous cartograms are constructed is we're sort of warping the space a little bit at a time. And this iteration max equals 5 says that we're going to do it a maximum of 5 times. And what should happen is that the precision should increase as we go. So the first round, we've got some problems with our scaling, but as the iterations continue, then the overall error gets smaller as we go. It's often not necessary to make a perfectly high fidelity continuous area cartogram because people aren't going to be able to tell the difference. And so if the error is small enough, it won't really matter. So we're just going to copy and paste that line in here. This is going to run the iteration. It shouldn't take long once it gets going. And these numbers should match more or less what you see. Now, if we wanted to make this more precise, we could change that value to something else. The actual number of iterations that you use is kind of a bit arbitrary. And again, having a lot of iteration doesn't necessarily really improve the result necessarily. But you can see that the overall error is getting smaller as we go. The next stage is to plot it. So we can just hit Control-C and we can plot this, and we'll get a cartogram over here on the right, which we can resize, we can manipulate. Again, that's something for, I think, a future session, but it would be enough to sort of just use your snipping tool to copy and paste this into your notebook for this particular piece. So one of the beauties of using R to do this is that it's actually pretty easy to manipulate what you're seeing. So embedded in this package are other ways to make cartograms. The research says that quantitative variables are actually not particularly well understood when people use a continuous cartogram like this one. And so non-contiguous cartograms may actually be more effective. It's quite easy to do this. So to do the construction of the cartogram, this is actually quite a bit easier. So all we're doing is we're scaling the size of the polygon to basically a function of the original area and a ratio of the maximum of the variable that you're using, so population to the actual population of the polygon that you're working with. So there is no iterative step here. It's a straight numerical calculation. And then to plot it, it's basically the same sort of idea. We can just plot it here, and you can represent, you can get this exact same cartogram that you see. So copy and paste that into your notebook as well. The last one is this one. So this is the non-overlapping circles cartogram. This is essentially a version of a door lane cartogram. So we're pasting this in here. We're creating an object for our Africa door lane cartogram. And then we're just plotting this as well. So copy and paste. All right, so we get something that looks like this. One of the nice things about this versus the just doing a proportional circles map is that the position of these circles has been adjusted so that they're not overlapping, which is a really nice visual element to sort of declutter the field and make it a little bit easier to see. So this is a pretty effective way. Here we're using color or gray tone really, plus the size. Both of those variables are acting together to communicate this idea of the difference in population. There's a lot more that you can do with this. Within R, you can add labels. You can do a lot of other things. We'll leave that for a future session. But this is just a quick basic overview of how to get started making a cartogram in R.